This temple was not assembled from blocks. Its central monument emerged by removing the mountain that once completely surrounded it. Kailasa at Ellora is Cave 16, the largest monolithic temple in the complex and one of India's greatest rock-cut achievements. From above, the engineering logic becomes visible. A deep, open courtyard separates the freestanding sanctuary from the surrounding basalt cliff. That means builders solved architecture in reverse, defining finished forms by deciding exactly which parts of the mountain to remove. The popular phrase is top-down excavation, but stronger evidence supports a broader idea. That changes the mystery. The question is not whether machines vanished, but how planning controlled irreversible cuts at monumental scale. Ellora contains 34 monasteries and temples extending more than 2 kilometers along a high basalt cliff in Maharashtra, Western India. UNESCO dates the site's continuous sequence broadly from the 6th through 10th centuries, with Buddhist, Hindu, and Jain monuments together. Kailasa belongs to the Brahmanical group, where Cave 16 represents what UNESCO calls the culmination of India's rock-cut architectural tradition. Unlike an ordinary cave excavated mainly inward, Kailasa creates freestanding architectural masses surrounded by open space inside the carved courtyard. The complex includes a main temple, Nandi shrine, entrance gateway, and cloisters cut into the rock around the central courtyard. That layout deliberately imitates constructed architecture, even though the principal forms were produced by excavation rather than assembled masonry construction. Official Maharashtra historical records attribute the great Shiva temple to Rashtrakuta ruler Krishna I, reigning during the 8th century. Archaeological Survey of India material likewise says the Kailasa project started under Krishna I, ruling from 757 to 773. That dating places the monument inside a sophisticated medieval architectural world. Scholars also connect its design to southern Indian Dravidian temple traditions, already visible at places such as Pattadakal before Kailasa. A peer-reviewed study notes especially close similarities with the Virupaksha temple in plan, sculptural. So Kailasa was radical in method, not culturally isolated. Its designers translated an established architectural language into living basalt rock. An Indian cultural institution describes Kailasa as cut from one piece of rock from top to bottom and open sky. From the rim, deep vertical separation around the monument makes a downward excavation strategy physically understandable without inventing hidden machinery. Workers first had to establish the volume that would remain, because every removed layer permanently changed the dimensions available below. The exact sequence is not preserved, so detailedly animated reconstructions should be treated as models rather than recovered historical footage. What is secure is the subtractive principle. Architecture exists because enormous basalt volumes were removed while selected rock remained behind. Maharashtra's official gazetteer describes a rock scarp over 100 feet high and a complex roughly 300 feet long. It gives the area as roughly 300 by 175 feet. Showing the extraordinary footprint of the excavation. Inside that space, the main sanctuary rises freestanding, while galleries remain physically connected to the surrounding rock walls and cliff. A Nandi pavilion stands along the temple axis, reinforcing the appearance of a conventional Shiva complex carved instead from bedrock. Two monumental pillars and life-sized elephant sculptures complicate the courtyard because their final forms depended on rock deliberately left behind. Every element required coordination between empty space and surviving stone, making excavation itself a fundamental part of the architectural design. Built architecture can replace damaged blocks. Monolithic carving allows fewer corrections because material removed from parent rock cannot simply return. That does not mean one mistake destroyed everything, but major geometric errors could force redesign or sacrifice intended architectural details. Surveying therefore mattered as much as carving. Alignments, heights, wall thicknesses, the surviving monument shows control of symmetry and proportion across spaces created by removing rock carefully in several coordinated directions. Kailasa becomes an engineering story rather than a supernatural one. Organization converts simple. The achievement is cumulative precision across countless decisions, not evidence that builders possessed an undocumented machine capable of dissolving mountains. Ellora is carved into basalt from ancient Deccan volcanic activity, and the rock shaped which excavation methods were practical there. Estimates.
Geological field studies at Kailasa describe basalt flows, mineral textures, and natural fractures.
These fractures mattered physically, but published evidence does not justify claiming builders followed one universal crack pattern throughout the temple. The safer interpretation is that experienced stoneworkers learned local basalt behavior, then adjusted quarrying and finishing to each working surface.
Generic hand tools are reasonable historical context, but exact tool sequences at every stage of Kailasa are not documented manuals. Hansen. Our reconstruction should show controlled stoneworking without pretending.
Kailasa was dedicated to Shiva, and its architecture presents the earthly temple as an artistic evocation of sacred Mount Kailasa. Archaeological survey material notes the monument once carried white plaster, strengthening its symbolic association with a snowy sacred mountain landscape. The courtyard includes Nandi, Shiva's bull, while the inner sanctuary houses the linga that defines the temple's central devotional purpose. Across the complex, sculptural programs include Shaiva and Vaishnava deities, epic narratives, guardians, legends. UNESCO particularly highlights the celebrated relief of Ravana attempting to lift Mount Kailasa beneath Shiva. Fragments of paintings survive on ceilings of the front mandapa, reminding us Kailasa was never experienced as bare stone originally. The monument's architectural language links excavation with wider Indian temple building history, especially developments across. Researchers have long compared Kailasa with Virupaksha at Pattadakal, a structural temple completed before the Rashtrakuta project at Ellora began. That comparison matters because it gives the carvers a three-dimensional architectural vocabulary they could reinterpret through subtraction rather than construction. Columns, halls, towers, gateways, shrines, and sculpted walls belong to recognizable temple traditions, even when carved from one rock mass. Kailasa's innovation was not inventing temple architecture. It translated constructed forms into an art. This combination of inherited design and radical execution explains why UNESCO describes 16. Krishna I anchors the project historically, but the finished complex should not automatically be reduced to one ruler's reign. Archaeological and art historical sources place important work from the mid-8th into early 9th century, with later activity elsewhere throughout Ellora. That longer horizon matters because viral calculations divide speculative rock tonnage by few years, then declare human construction impossible outright. The original short cited over 200,000 tons, but authoritative sources here provide no single agreed excavation tonnage figure.
This long-form episode drops that number instead of converting an uncertain estimate into a dramatic claim about daily rock removal.
Likewise, we avoid claiming precise workforce, exact completion time, or one unbroken construction sequence.
Kailasa does not become less extraordinary when exaggerated statistics disappear. Its verified architecture already demonstrates exceptional planning and sustained labor.
UNESCO calls the temple a technological exploit without equal when considering excavation itself, language strong enough without adding technology claims.
The visible monument preserves human design traditions, recognizable temple forms, historical patronage. What we lack is not human authorship evidence, but a complete diary recording every measurement, crew, tool, and intermediate phase.
That distinction matters. Missing details create legitimate research questions, but they do not automatically prove machines absent from historical record. The strongest mystery is procedural. How were thousands of irreversible decisions coordinated across a monument of this scale and complexity? Stand above Kailasa today and the central fact is unmistakable. Builders transformed basalt cliff by controlling removal and preservation carefully. They removed rock to create courtyards and separation, while preserving masses needed for towers, halls, pillars, elephants, and shrines below. They worked inside an established religious and architectural tradition, yet pushed rock-cut design toward a UNESCO. The evidence supports human engineering, inherited design knowledge, and organized craftsmanship. What remains impressive is documented. A mountain became architecture through subtraction, measurement, sculpture. Kailasa shows ancient engineering can look impossible when we see only the finished object and forget accumulated process behind it. Episode 20 moves from India to China, where another monumental stone project preserves the opposite ending. Ambition stopped before completion. At Yangshan Quarry near Nanjing, 3 enormous Ming-style components remain unfinished, including an officially estimated 60. Kailasa shows what subtractive planning completed.
Yangshan asks what happens when monumental stone